Section 4.1, Additive, Multiplicative, and Ciphered Systems of Numeration. Systems of numeration. A number is a quantity. It answers the question, how many? A numeral is a symbol, such as those shown there, used to represent the number. A system of numeration consists of a set of numerals and a scheme or a rule for assigning the numerals to represent the numbers. The types of numeration systems that we're going to discuss are 4 types: additive, multiplicative, ciphered, and place value. In this video, we'll go over the first 3. In the additive system, this is one where the number is represented by a particular set of numerals, and we simply sum up the values of the numerals. It's one of the oldest and most primitive types of numeration systems. Examples are Egyptian hieroglyphics and Roman numerals. Egyptian hieroglyphics are shown here, and we see the symbols that they use, the numerals that they use, and the values of those in our system. And our system in the United States is called the Hindu-Arabic system. Write the following numeral as a Hindu-Arabic numeral. So what we do is we look at the table of the numerals for the hieroglyphics, and we see that these fingers here, they're called pointing fingers, are each worth 10,000. The scrolls are worth 100. The heel is worth 10, and then 4 staffs are worth 1 each. So we add up the values of the symbols or the numerals to get the value of the number. Now we want to go the other way. We want to write this number as an Egyptian numeral. So we first of all break it up into pieces. So we see it's 1 million plus 200,000 plus 3,000 plus 400 plus 60 plus 2. And then we look at our numerals in the Egyptian system, and we replace the numbers in our system and the numerals in our system with the symbols or numerals in that system. So we have the astonished person is 1 million. The fish symbol here represents 2 of those, each are worth 100,000. The next numeral here, and so forth. In the Roman numeral system, which many people are familiar with, here are the numerals that we have. There are 2 advantages here. It has a subtraction principle as well as an addition principle. So for instance, if you put the numeral D and then follow it by C, that means 500 plus 100 is 600. If you put them in a reverse order where the numeral to the left has a smaller value than the numeral to the right, that means to subtract. So 500 minus 100 is 400. And then a multiplicative principle, we put a small horizontal bar over the symbol, and that means to multiply it by 1,000. And there's 2 examples there. So we're going to write this Roman numeral as a Hindu-Arabic numeral. So we want to take the value of the symbols that we see there. So we break it up into CM, because again, notice that this C is worth less than the M, so we know we're going to subtract here, plus an L, plus an X, and then again, we have a symbol to the left of a symbol with a larger value, so we know we're going to subtract again. So this is right here is going to be 1,000 minus 100, plus 50 plus 10 plus 5 minus 1, and we add those up and we get 964. Now we're going to go the other way. Let's write 439 as a Roman numeral. So again, break it up into parts, 400 plus 30 plus 9. Now remember, 400 we can write, instead of using 4 of the numerals for 100, we can use the subtraction principle and take it as 500 minus 100 plus 3 tens plus 10 minus 1 to give us 9. And there's what it looks like in the Roman numeral system. In the multiplicative systems, these are more similar to the Hindu-Arabic system which we use today. We have Chinese numerals, shown here. And these are a little different because they're written vertically. And so we go from top down, we go in groups of 2. And what happens is there's going to be a numeral over top of a numeral that's a power of 10. And you're going to multiply. So this is 2 times 10, which gives me 20. This here is the numeral for 4, and it's over the numeral for value of 10, so it's 4 times 10. So let's write 538 as a Chinese numeral. So again, break it into parts, 500, 30, and 8. So the 500 will be represented as a 5 over the numeral for 100. The 30 will be represented as 3 over the numeral for 10. And then we finish up simply with 8. We don't put it over a 1. We simply leave it as a single units at the bottom. Ciphered systems, they have numerals for numbers up to and including the base, and then for multiples of the base. The numbers are represented by a particular set of numerals and is the sum of the values of the numerals. Ciphered numeration systems require you to memorize many, many symbols, but you can write numbers in a very compact form. Examples, we're going to study the Ionic Greek system that was developed about 3000 BC, and it used the letters of the Greek alphabet as the numerals with a base of 10. And it also has a multiplicative feature where the symbol iota placed to the left and above a numeral represents that numeral multiplied by 1000, similar to Roman numerals. Examples of ciphered systems are listed here. And here's the Greek. Now remember, we said there's going to be a lot of symbols. And so here we see 1 to 10, and then we have multiples up through 100, and then we have multiples up through 1,000, and then up to 900 actually. Beyond that, we're going to use the multiplicative feature with that iota to the left of the numeral to signify to multiply by 1,000. So let's write this Ionic Greek numeral as a Hindu Arabic. So again, looking up in the table, the first numeral is worth 300, the second one's worth 80, and the third one is worth 5, so we simply add those together. If we want to go this way, 1654, and we want to do this as an Ionic Greek numeral, so we want to break it down into its parts, 1,000 plus 600 plus 50 plus 4. So again, let's look at the pieces we have here. And we notice to get to 1,000, we're going to use the numeral for 1 and use the iota symbol up to the left to show multiplying by 1,000. And we do have a numeral for 600 and one for 50 and one for 4. And there's what it looks like. Write the given numeral as numerals in Hindu Arabic. So we're going to go through one number and write it into all different systems. Okay, so the first one they're giving me is in Chinese, and we want to know what's the equivalent Hindu Arabic numeral. So again, we take it in groups of 2, starting at the top. So we look at the top 2, and we look at that top symbol there, and we notice that looks like the symbol for 4 over the symbol for 100. So this represents 400. We take the next group of 2 numerals, and we have a 3 over 10, so that's going to give us 30. And then finally at the bottom we have a 6, so this is 436. Now remember, this in Chinese system was 436. Now we want to translate it to the Egyptian system. So we have 400. So we look at our symbols down here. So we know we're going to need 4 scrolls. We look here, we have 2 answers with 4 scrolls. So it's going to be one of those. And then we need a 30s. So we need 3 heel bones. And we see that in answer C. And then we need 6 staffs. And that's right here. So the correct answer here is going to be C. Now we want to take it to Roman numeral. So we have 436. So how are we going to write 400? Remember, we did that one before. That was CD. 30 is going to be XXX. And then 6 is going to be VI. And then finally, we want to do it in the Greek system. So we want 400. So we look in our table here for 400. We see that symbol right there, upsilon. We look in our answers. It looks like the only one that has an upsilon is B. Let's make sure that's correct. And then we need a symbol for 30, which is the lambda. And then we need a symbol for 6, which is the digamma, and so the correct answer there is B.